So our factoring guide, one thing that you could either, if you do happen to have a highlighter, great. If not, just put a star by this or highlight this. When we factor, no matter if I have 2 terms, 3 terms, or 4 terms, I would always check to see if I have a greatest common factor. If we have a greatest common factor, we have to take that out. Okay, so let's talk difference of squares. Okay, this is a review. We've already seen it. We've already done it. It was actually number 1 on your homework from Friday. A difference of squares breaks up into 2 binomials, and it's going to be a plus b times a minus b. Now, somebody asked me earlier, does it matter if you put the plus first and then the minus? And the answer is no. You could go minus and then plus, and you'll be the exact same answer. Okay, so that's my factor pattern for difference of squares. We're going to take a look at a couple of examples together. The first example we're going to do, we're going to start really easy, is x squared minus 9. That is a difference of 2 squares. X squared has a perfect square, 9 has a perfect square. That's going to break up into 2 binomials. And we've done this before, guys. We did this like before Thanksgiving. You also saw this in Algebra 1. We take the square root of x squared. What's the square root of x squared? Okay, that goes in the first space. Then I take the square root of 9. Square root of 9 is? And my signs have to be different. And so I'm going to just make a little note of that. Signs are different. 1 positive, 1 negative. You could go negative first, then positive. Do you guys remember doing factoring like that? Difference of 2 squares. We've seen that quite a few times. Okay, we're going to try another example because one of the things that they'll sometimes throw our way, and this was on our practice last week, is if they gave me something like this, 16x to the 4th minus 25. And that throws a lot of students like, wait a minute, the exponent's 4. That's not x squared. But you could still take a square root of that. This is still the difference of 2 squares. It's going to break up into 2 binomials. I have to take the square root of 16x to the 4th. What's the square root of 16, guys?
4.
Okay. What's the square root of x to the 4th, you think? X squared, yeah. Because if you multiplied it, 4x squared times 4x squared, that's your 16x to the 4th. Okay, square root of 25 is, and then don't forget your signs have to be plus and minus. Okay, I'm going to add another little note down here. We could check these with the FOIL method. If I wanted to see if I got it right, I could just multiply it all back together and see if I get what I started with. Okay. Let's try one more. We're going to take a look at 48x cubed minus 3x. All right. Now, it is a difference. I see subtraction. I have 2 terms. But one thing that's kind of weird to me is I've got a 48 and a 3. If you look at our numbers of perfect squares, neither one is a perfect square. So this is a situation where we need to, I'm going to minimize this for a second, we got to look for that greatest common factor first. Think about those numbers, 48 and 3. What number could go into 48 and 3?
16.
3.
16.
Well,
16 goes into it 3 times. No.
Yes. But greatest common factor would be what can divide into 48 and into 3. 3. Okay, now could I take an x out? How many? Just one. Do you remember the rule? What is the rule of if they both have the variable? Good, Jake. You take the lowest exponent. So my greatest common factor is going to be 3x. Hey, guys, you put the greatest common factor out in front, and then we're going to divide it. That's mathematically how we're getting it out of there. We're dividing everything by the GCF, which is 3x. So as these guys were saying, yeah, 48 divided by 3, that is 16. So that's going to be 16. We saw this on our quiz last week. When we divide, what do we really do to those exponents? subtract. So 3 take away 1, I get x squared, bring down the minus, and then here it's 3x over 3x, which is 1. Okay, now a big mistake a lot of students make is they'll just stop there and be like, okay, cool, I'm done. But that was just the first step. We had to take out the greatest common factor because now what's hiding out in here, this is my difference of 2 squares. So we continue, we bring our 3x down. That's part of my answer. Difference of 2 squares breaks up into 2 binomials. I take the square root of the first term. So square root of 16x squared is 4x. I take the square root of the last term. So square root of 1 is 1. And my signs are opposite, 1 positive, 1 negative. That's going to be my final answer, all of that with the 3x. Again, I could check if I foiled it and then just distributed the 3x. That would get me back to my answer. So this is a review. We've seen difference of squares many times throughout this school year. Okay, do you guys remember, hopefully? Yes. Okay. Let's continue on with review, stuff we already should know. Let's take a look at our trinomials. So if you look at the first thing of the trinomials where it says a equals 1, guys, this is kind of like, I would say, the easiest type of trinomial. I'm going to highlight this, and I'm going to write right above this standard form. What do they mean when they're saying a? Your trinomial is ax squared plus bx plus c. That's like our standard form for a trinomial. Okay, if I had something like this, I'm going to give you one like this. 3x squared plus 3x minus 60. Okay. In this problem, my a is not a 1. My a is a 3. I have to stop and ask myself, is there a greatest common factor? What do you guys think? 3. So if you have one, you have to take it out. I'm going to pull the 3 out in front, and I'm going to divide everything by 3. That's what we do first. So now I've got x squared plus x minus 20. Now, we're not done. Now we factor what's inside. So I'm going to keep the 3, but I'm going to break that trinomial into 2 binomials. Now, this is stuff we've done a lot. Who could tell me, what am I going to put in the first space here and here?
X squared.
X, because x times x gets me x squared. So that's going to be an x, that's going to be an x. Now, with these trinomials, I'm going to make another note over here. For my mystery numbers, they need to multiply to c, and they have to add to b. So at this particular moment, I'm looking for numbers that can multiply to be a negative 20 and add to be a 1. You got it? Oh, yeah.
Oh.
I thought you were going to say you knew what this would be.
Negative 4 and 5.
Yes, good, Jaden. Negative 4 times 5. Negative 4 times 5, that gets me negative 20. And then if I added negative 4 plus 5, that gets me 1. Negative 4, positive 5. That's the answer. Again, I could check this with the FOIL. If I FOILed it and then just distributed by 3, that would get me back to my answer. This was kind of my easier factoring. Hopefully you guys feel okay about that. Yes, no, maybe? We tired today? It's the end of the day. It's a Monday. I sense the energy is very low right now. Okay, I'm going to have you guys try this one for me. It's kind of an easier one, but I want you to try to do x squared minus 6x plus 5. Give that one a try. So we know we're going to break it up into 2 binomials. This guy does not have a greatest common factor. We know it's going to be x and an x. In this case, what do the mystery numbers need to multiply to be, guys? I'm looking for numbers that multiply to be what? 5 and add to be -6. So what's that going to be? What can multiply to be a +5 and add to be a -6? Jay Sean, what can do that? Thank you. -5 and -1. A negative times a negative is a +5, but if you add them, you get that -6. -5, -1. That's it. Pretty easy. Guys, today, for the purposes of like not only this thing that we're filling out, but for our quiz that we're going to take this week, this little project thing, it's just factoring only. We're not solving, okay? All right, so let's take a look at the trinomials where A is a number. That's going to be the next level. This is also a review. We've done this in the past. So this time they say A is greater than 1. Class, we're still talking about our standard form, AX squared plus BX plus C. Here's what's different. When you have that number up in the front, those mystery numbers need to multiply to be A times C. They're still going to add to B. So we have a little bit of a difference. And we're going to come in with a problem that actually has a larger number up front to multiply. So we're going to take a look at 2x squared plus 15x minus 77. Now, you can see just on those numbers alone, like a 2, a 15, a 77, none of those have a perfect square root. Or, sorry, a greatest common factor. So we can't take anything out. We have to just kind of go with it as it is. So what I'm going to do is I'll start off with my 2 binomials, like what we've been doing. Does anybody remember from doing this type of factoring in the past? This time, what would I put in my first space here and here? Previously, on those last ones, you did x and an x. Mm-hmm. Now I got a number up front. 2x. Thank you, Lynette. So I'm going to go 2x and 2x. And you might be thinking, well, that's not going to work because if I FOIL, 2x times 2x would be 4x squared. This is just kind of like a placeholder. It's going to help me to get started on the problem. Now, what's a little bit more challenging when you have the number up in the front, your mystery numbers here have to multiply to be A times C. So at this time, I have to do 2 times -77. I'm looking for numbers that multiply to be -154. That's a big number. Off the top of my head, I have no clue of the things that multiply to be -154. I have to add up to be B. That means I'm adding to 15. This is the part, guys, where it's trial and error in your calculator. You've got to do 154 divided by 4, 154 divided by 6, and you got to try to see what you can find that goes into it. So take a moment. I want you to try that. Honestly, when you get these bigger numbers, that's what gets a little bit harder. I honestly cannot remember. Okay, I got it. Anybody else have it? It's really weird. Now, this would require you to actually pick up the calculator. I think I only see like one person actually using the calculator. So you have to actually try this. You do 154 divided by 5. Well, you know 5 won't go in. 154 divided by 6. 154 divided by 7. Try, plug things in. We've got to figure out what goes into it. Jake, did you save our drowning ship here? What'd you get?
+22 and -7.
Ding, ding, ding. Winner, winner. 22 times negative 7. Guys, it is harder when you get these bigger numbers, but you have to actually just plug something in. So yes, we're going to take a positive 22 and a negative 7. But now that leads back to what we said at the beginning, that we can't leave that as the final answer. Because if I was going to FOIL, I wouldn't be right. I've got this final step, which is that division. So you look at the first binomial. You've got a 2 and a 22, and you have to think about what could go into 2 and 22. 2 could. So we're going to divide the first binomial by 2. We'll get x plus 11. I look at the second binomial. I've got a 2 and a 7. Well, nothing goes into 2 and 7, so we're going to leave that as 2x minus 7. Okay? All right, here's what I want you guys to do. I want you to try this. If you think you have this answer right after I put it up here, I want you to raise your hand. Well, once you get it, I'll check it. If you get it right, I'm going to give you a snack. Because I need people to wake up. I need people to try things. So it's 6x squared minus 13x minus 28. This guy does not have a greatest common factor. So you have to start this out with doing 6x and 6x. Those mystery numbers, A times C. We've got to go 6 times. We're going to get a big number again. The mystery numbers have to multiply to be negative 168, and we add to the middle. This is where you've got to kind of test it out, see what it is. Well, first off, it's finding those mystery numbers. Jay Sean, what did you tell me it was that multiplied to negative 168, added to negative 8 and 21. Okay, now that's not the final answer though. Now you look for what could go into it. With a 6 and an 8, 2 can go into that. So we'd have 3x minus 4. With a 6 and a 21, it's 3. 3 can go into that. So you get 2x plus 7. Okay, write that down the right way. We want to make sure you have the right thing on your paper.
Isn't that positive?
Yeah, it's negative 21.
Jay Sean. Oh my gosh. Okay, so, scratch that. We have to make some changes. This is a negative 21 and a positive 8. So positive 8 and negative 21. Okay, so then that's going to be a positive here, and then this guy changes to negative. My bad, guys. Sorry. But good job for those of you that did get it. Okay, now all of that we've covered so far is review. We've already done difference of squares. We've already done factoring trinomials. What we're going to move into now is the new stuff. So if you were here Friday, you saw this. If you weren't here Friday, I'm going to kind of go back over it. We're going to start with this sum of cubes. And what I'd like us to start off with is writing the rule. The rule is on my whiteboard. My sum of cubes is A plus B times A squared minus AB plus B squared. And I told you guys, I'll give you that. That's on the whiteboard. That you'll never have to memorize that. But we do need to know how to use it, okay? So taking a look at an example of a sum of cubes, we're going to start kind of easy with x cubed plus 27. Now, both of those have a perfect cube. Friday, we wrote out our perfect cubes. 1, 8, 27, 64. This is how we got them. 1 to the third, 2 to the third, on and on. Okay, so this is going to break up into first the A plus B. To get that, kind of like difference of squares, I'm going to take the cubed root. So we take the cubed root of x to the third. Guys, a cubed root, exponent of 3, cancel out. That just is x. Then we take the cubed root of 27. Well, the cubed root of 27, if you look, the cubed root of 27 is 3, because 3 to the third is 27. So it's x plus 3. When you do sum of cubes, or in a moment we do difference, these signs always stay exactly the same. You're never going to change those signs. So I have x plus 3. I don't have a and a b. My a is the x, my b is the 3. We use this as like our outline and skeleton. So the next thing I have to do is a squared. Well, my a value is x, so that'll be x squared. Bring down the minus sign. Now I'm a times b. Here's a, here's b. X times 3, 3x. Bring down the plus sign. Now I'm b squared. Well, b is 3. What's 3 squared? 9. That's going to be my final answer. So it is a little weird, but we're just following the pattern, really. That's all we have happening. Okay, now, if you look at my whiteboard up here, one of the things I added, like cubed root of x to the third, that is just x, because a cubed root and the exponent of 3 cancel out. But look right here. The cubed root of x to the 6th is x squared. The cubed root of x to the 9th is 3, because I'm just dividing it. 6 divided by 3 is 2. 9. So you're going to see maybe not just x cubed. I'm going to show you an example where we're going to have a different exponent. So our next one, let's try to do 8x to the 6th plus 1. Okay, to get that first binomial, I've got to take the cubed root of 8x to the 6th. Oh, I thought you were going to answer. Yes. I was like, yes, Chloe, you got it. Okay, cubed root of 8 is 2. Cubed root of x to the 6th is x squared. You're doing 6 divided by 3. It's kind of weird. What's the cubed root of 1? 1. And that should be a plus. Now, what I'm doing is I'm following this. This is my rule up here. This is my outline, my skeleton. Everything has to fall into this guy. So we got our a and our b. Our a and our b this time is 2x squared and a 1. So for a squared, I'm doing 2x squared squared. Think on that for a second. 2x squared squared, that means 2x squared times 2x squared. 4x to the 4th, yes. So we got 4x to the 4th minus, now the next thing I'm following is a times b. Okay, that's my a, that's my b. 2x squared times 1, that's just 2x squared. I don't know why that box got in there. And then I do plus b squared. B squared is the last term. B is 1. 1 squared is 1. This is the new stuff. Sum of cubes. Okay. I'm going to give you guys one to try. 216x cubed plus 125y cubed. Last one. Try that. This has perfect cubes, so you don't need to factor anything. We're just jumping right into it. It's going to break up into that factor pattern. Now, again, if you want to rewrite that factor pattern out, do it. A plus b, a squared minus ab plus b squared. Let's go ahead and jump into this. So first we take the cubed root of the first term. So cubed root of 216x to the 3rd is 6x. Then we have to take the cubed root of the last term. So that's going to be 5y. Okay, now I'm following through. A squared would be 6x squared. That's 6x times 6x, or 36x squared, minus a times b. So 6x times 5y, that's 30xy, plus b squared. Well, your b value is 5y, so I'm doing 5y squared. That means 5y times 5y. That's going to give me 25y squared. This is what we covered Friday. We're just reviewing it. We're practicing our rule. Good job to those of you that got it.
When's the test?
Well, it's a project, Gavin. Yeah, I'll explain it. Okay, let's go to difference of cubes, guys. It's honestly almost identical, just different signs. So for difference of cubes, your pattern is A minus B, A squared plus AB plus B squared. All I've changed is where I'm putting a plus and a minus sign. But again, you don't have to have that memorized. We just need to know like where to put everything, okay? So let's just take a look at a couple here. First example is going to be 64 minus x cubed. It's a difference because they've got subtraction. If you notice, 64 has a perfect cube, so I'm looking at a difference of perfect cubes. We start off by taking the cubed root. So I need the cubed root of 64, which is what, guys?
4
Okay.
cubed
Minus, what's the cubed root of x cubed?
x.
Boom. There's your A and your B. Now you plug it in. Okay, so A squared is first. Well, my A is 4. So 4 squared is 16. Keep the signs exactly the way you see them. Bring down the plus. Next, I'm doing A times B. 4 times x is 4x plus B squared. Well, my B is x squared. That's it. That's the answer.
May I use switch?
When Ryan gets back. Okay, you guys give this one a try. 27x cubed minus 8.
No.
Yes. All right, let's see what happens here. So, Gavin, what's the cubed root of 27x to the third?
9x.
No. Cubed root of 27?
3.
3x, okay. And how about cubed root of 8? Wyatt, cubed root of 8?
2.
Good. So it's 3x minus 2. That's my A and my B. So now we're plugging that in to our pattern. So your A is 3x. Right here, A squared, that's 3x squared. 3x times 3x, we get 9x squared. Keep that plus sign. Then it's A times B. A times B. 3x times 2 is 6x. Bring the plus sign down. The signs stay the same. B squared is the last thing. Your B is 2. So 2 squared is 4. That's going to be my answer. Okay. All right, guys. We've got one final thing. Sorry, I know this is a long day. Right now, Ryan's out, so you have to wait. Okay, last thing we're going to talk about is 4 terms. Okay, so take a look down at that last section. We've got one more example, you guys. I know this is not the most fun day here, but we'll get through it. Okay, we're going to take a look at x cubed plus x squared minus 9x minus 9. Okay, can you end your pass? We got like a whole line waiting to go. Okay, when you have 4 terms, you guys, we have to make groups. So the first thing we're going to do is we're going to make 2 groups. Guys, always join them with a plus sign. So in this case, I'm going to make my first group x cubed plus x squared plus. You have to join these 2 groups with a plus sign. Slide the last 2 terms in the last set of parentheses. Negative 9x minus 9. Each group needs a greatest common factor. In my first group, I've got x cubed plus x squared. What would the greatest common factor of that be? X squared, very good. X squared comes out in front. That's the greatest common factor. To take it out, I'm dividing. We're dividing everything by that GCF. Okay? When you divide, we're really subtracting those exponents. So x to the third over x squared gives me x. Bring down that plus sign. X squared over x squared gets me 1. Bring down your plus sign. One of the things we talked about on Friday is if your first term is negative like this, we have to take out a negative. So when I'm thinking about the GCF over here, I've got a negative 9x, a negative 9. The GCF is going to be negative 9. You've got to take out a negative 9. So we're going to divide everything over here by negative 9. Watch those signs. A negative divided by a negative, that's going to be a positive x. Negative 9 divided by negative 9, that's a positive 1. Okay? Now, one thing that I told you guys on Friday is after you do this step, you can do a quick check to see if you're doing it correctly. These two binomials, this guy and this guy, have to be exactly the same. If they're not the same, you did something wrong. So now that I'm the same, I can go ahead and, I kind of say like marry my groups together into two binomials multiplied. The first group is going to be your greatest common factors. So I'm going to take my x squared and my negative 9, and I'm going to put that here. That's going to be the first part of my answer. The second group is going to be what we call our common binomial. Whatever I got to be the same, that's what's going over here. X plus 1. Okay. Raise your hand if you think you can tell me what one more thing I can do. There's more factoring involved. Look at that. Look at those two binomials. There's something hiding out in there that we've already talked about today. Come on. Look back at that. Jake. Boom. Jake. Yes. Do you like Cheetos, Jake? I was going to throw some Cheetos at you. Okay, so Jake's right. He said that's a difference of 2 squares. It is. So this is like an amazing problem because now we got more to do. Difference of 2 squares breaks into 2 binomials. What's the square root of x squared? What's the square root of 9? Signs have to be different. One positive, one negative. Now we're just going to bring this guy down. X plus 1. That's going to be the final answer. Woo. Okay. What I would recommend, put your name on that paper.